Hello, Avnish. Am I audible? Yeah, Avnish, am I audible? Akshay, Aditya, am I audible clearly? Yeah, please speak up, someone. Ankit Saurav, am I audible? Ankit, Ankit Saurav.
Yes, sir.
Yeah. So the class is from 12:50 to 1:40. So I'll be starting within 1 minute. Just waiting for some people to join in. Yeah. So I'll be starting right now. It's gone. So in the earlier class, what we have been doing is it was only the AC drives. So I'll just give you a revision of what we did in the earlier classes. So in the earlier classes, we did rectifier based DC drives, right? So for that, we went to single phase, whereby we had, say, fully controlled half wave or full wave rectifiers. Out of that, we had some asymmetrical waveforms, asymmetrical circuit, then symmetrical ones also, right? Now, all these are over, huh? And single phase and three phase was also there. So after this, we come to DC-DC based chalkboard based drives, right? So DC-DC is used where the input source, where the input power source, actually it's a called power source, is a DC source, right? It's a DC source. So give me an example of such a thing. Can anyone give me an example of where the input source is a DC one? Anyone there? Avnish, Sunil, Ankit, Samir. Any example where the source is a DC1? Akash, Sunil. Okay, so let me clarify that the DC source can be this EV based electric vehicle in which the battery is a pure DC source, right? Pure DC source of the battery, right? So in that case, the source is DC and the output is an AC, so we need an inverter. But there can be certain cases where the motor itself is a type of DC motor. So in that case, it would become a DC-DC chopper based drive. So, just a second. Yes. So what are the main features? It is used only when variable DC is obtained from a fixed DC supply. Then traction system use choppers extensively. Choppers is easily adaptable for regenerative braking. I have also shown a video whereby this is very nicely implemented in 4 quadrant chopper in the previous semester, right? Now, chopper drives are also used in battery operated vehicles very easily this time. So, what are the modes of operation? There will be 4 modes of operation, as you know, first quadrant, second, third, fourth. But other than that, we have the motoring mode also, regenerative braking mode also in both the directions, and we have 2 or 4 quadrant of choppers. Going to the next. So quadrant one chopper. So that is type A chopper. It is only meant for motoring action. And here you cannot have the reverse power flow from the load to the source. So in that case, this would be the circuit diagram. Well, this transistor is in the lower domain, not here, right? So this is a, say, this is a type of IGBT or maybe a MOSFET, depending upon the frequency of operation. And this is the freewheeling diode that we everyone know. So this is the motor. So earlier, what our circuit used to be for a buck converter, it used to be something like this, right? But now we have the complete motor as RLE load. This is the R, L, and E load. We may or may not attach a capacitor also, that is up to us. But the essence is that for the implementation of this circuit, only 2 devices are required. One is this, one is this IGBT, and one is the diode. So it is very, very simple to implement here, right? All the RLE is already embedded in the motor. Okay. So this is the chopper output waveform, whereas this is the duty cycle, DTS, and this is the 1 minus D into TS. Right? So during when the IGBT is switched on, the current through the armature increases, and then after reaching a certain peak, when it is switched off, the current decreases. And most of all, we should remember that the steady state current after the switch is off and when the switch is just turned on is the same. That is this one. And what is the average value of the current? It will go through the midpoint, right? It will go just through the midpoint. So this would be the average value of the current. So this is the T on time and this is the T off time. So how do you control the speed? The speed will be controlled. Its output equation will be T into V in will give the amount of V naught. So if you can change the value of V naught, you can have a change in the armature voltage also. The moment you change armature voltage, what will happen? The speed of the motor will change. The speed of motor will go up and down, right? So this is very efficient because there is no resistor trying to limit the current, right? So this is just switched operation. Yeah, any doubts? on this?
Sir, can you explain again? I joined late.
What you joined late? Okay. So say earlier we used to have this buck converter. Is it not so? We used to join this buck converter. Now with this buck converter, what was the equation? V naught equals to D into V in, right? Now what we have an RLE load. That is the motor. So this L which was extra in a buck converter, now we are getting it already embedded inside the motor. And this is the switch, that is the IGBT, and this is the freewheeling diode, right? So this is the freewheeling diode and this is the IGBT. So if you turn it on, power will start to flow through the motor. If you turn it off, it will circulate through the freewheeling diode. Is it not so? Right? And you may or may not put a capacitor also. So it's better don't put a capacitor, that will have an additional cost. So to implement this and to what is the only thing required? You need only a single IGBT and a single freewheeling diode. Is it not great that you can control the speed of just with only one IGBT and with one freewheeling diode, right? So it feels very nice, right? Now, so this would be the DTS. This is a T on time, and this will be a 1 minus D into TS. This would be the off time. So during the on time, the current rises linearly through the motor and then again goes down, and the level of this point should be equal to the level of this point. So because the value of current through the armature before the switch is turned on should be equal to that after it has reached this stage. So this value will be same. If it is not same, then the current will keep on growing. It will start to grow, right? So that means it is not at steady state, it is at the transient state. This only I explained. So the motor current decreases. Uh, so this is very self-explanatory. So what would be the torque speed equation? This would be the torque speed equation. Omega m equals to delta V by K minus RA by K square into T. So these are the steady state relationships. So what is delta V? Delta V is nothing but the duty cycle. So how do you get this equation? Just a second. So if you have this power supply and you are putting it here, this is the motor, this is that this is the IGBT, then what would be the equation? The V armature would be equals to, or V in is equal to IARA plus E back,
Yes.
right? Under
Yes.
steady state, where there is no transient conditions, then what would be the value of say IA? IA, the value would be V in minus EB by RA, right?
Yes.
But now V in is being chopped out, right? So it is having a PWM thing. So this V in will be having a term like D into V in, right? Why? Because you are not giving the full supply, you are cutting the supplies at some time. So that is the V naught equals to D into V in. This voltage is only getting implemented here, right? So that would be D to V minus E back by RA, right? So this is the equation that we got. So here D is actually written as delta here. Okay, now second quadrant operation. This is a simple boost converter in a reversed fashion. Just a second. Yeah, so this is a boost converter. So what would be a boost converter looking like? Boost converter would be looking like this. Right? We have one capacitor also, right? Now what is happening if I just reverse it? If I just turn this way to this side, what will happen? Say this is the source, this is the capacitor, and this load is actually a RLE load. This is actually a motor, DC motor, which is running at some speed, or it is being driven by another motor. So now if I put this IGBT and if I have a diode, then what will happen? The moment I turn it on, this this inductor will start to get magnetized. So it will oppose the inflow of current. So it will be plus and minus here in this fashion. The moment I switch it off, what will happen next? The inductor polarity will flip. So this will be minus, this will be plus, right? So E back, it is adding up to the VL voltage, right? E back plus VL voltage. So this will be greater than the V in voltage that was previously driving the motor, right? So what will happen? So this at this point the voltage is E back plus VL. At this point it is V in, and this is greater than V in. Right? So what will happen? This diode will forward bias, get forward bias, and it will charge up this capacitor, and this charged capacitor will slowly keep on charging the source, or it will supplement the source, right? So because if it is battery, it cannot get recharged within some few seconds, right? So this capacitor will get charged up. After that, it will supply this, or it may charge up this battery. So this is called as a regenerative braking action, right? Whereas the kinetic energy of this motor, that is half mv square, or this is actually the linear one.
Sir,
Yes.
so you have started from here, or
The first of all, you go to the recorded lectures after 2-3 hours. If you have any doubt, just come up, right? So this we have already taught in the power electronics section, right? So did you understand this thing, regenerative action?
can you teach again? Explain again, sir.
Every time you join late and the whole class has to go again through that. Huh? So I'm explaining once, just find it out. If you have any problem, just come to me. Second. Yes. Okay. So what about the boost converter? The boost converter was like this. Is it not so? The boost converter was like this.
Yes, sir.
Do you remember? Now what I am doing here, I am putting a RLE load, right? And I'm making this boost converter flip. I am just flipping this boost converter like this. So what I will have one source along with a capacitor. Then I will have this boost converter flipped, and I will have this RLE load. So this is the RLE load, and then finally what I will do, sorry for the diagrams, this would be the connection. So just tell me, if I close this S1 switch, what will happen? The current will start to flow. This is being driven by another motor or by the slope of the road. So this would be E back EMF, right? And this would be L. So if I turn on this switch, what will happen? It will try to magnetize the inductors.
Yes, sir, and it will flip.
And it will just oppose the inflow of current. Now if I turn it off, what will happen? It will flip, right? The inductor polarity will flip, right? The moment it flips, what is happening at this point? How much is the voltage? The back EMF gets added onto the inductor voltage VL, right?
Yes.
At this point, this becomes greater than the V in voltage. See, this is V in voltage, right? Then what will happen? This diode will become forward biased.
Yes.
Sir, how it is coming like EB plus VL?
Say if the inductor polarity flips, what will happen? Here will be plus and here it will be plus again for the E back. Then both are getting added up,
Hmm.
right?
Okay, okay. But VL voltage will be very, very high. How can you say that, sir?
See, if you just the thing is that if you are just trying to switch it on and off, the VL goes very high. LDI The DI is very high, na? DT is
Yes.
very low. So
Very small.
DI will be very high. So it will be in the range of 500 volts or maybe 200, 300 volts, depending upon the various values. It, depending upon L and all these things, it will very even
If the
if
sir, if the switch is closed, sir, if the switch is closed, then it could complete that one rotation, and it might not go that side also, sir.
just a
I
second.
mean, to through the diode.
Just a second. Yeah, tell me again. What is the
Sir, if
thing?
the switch is closed, it might not go through the diode.
It will not go. So you have two modes here. One will be what? So you have two modes here. So one is when this switch is on, right? So when the switch is on, what is happening? The back end is trying to magnetize the inductance here by sending a current like this. Is it not so?
Yes, sir.
So it will turn this as positive and negative because the inductor will try to oppose the inflow of current.
Yes.
Is it not so? Deep, are you getting it?
Yes, sir.
Why? Because VL is equals to L di dt, right? So if di dt is trying to increase, so VL will be positive as di dt is positive. Di dt being positive, VL will try to be P positive. Is it not so?
Yes, sir.
So
Yes.
what it will do? It will try to oppose. So both the L and EP are in
It
the
will try to
same.
oppose the change in current or increase in the
Yes,
current.
yes, yes. So this is V, this is EB now, right? Now in the second one, in the second mode, what is happening? In the second mode, the switch is off now, right? The switch is off, and now DIET will still be positive or negative at switch off condition. That value of current will try to decrease now. Is it not so?
Negative. That will.
So DIDT will be negative. So
Yes.
VL will be negative.
Hmm.
Is it not so?
Yes.
The other one, did you get it, Dev?
Yes, sir.
So what will happen? It will flip now. Here it will be plus and here it will be minus.
Hmm.
So E back is getting added on to VL or not?
Yes.
Yes, sir.
So this VL is actually very high. VL equals to LDIDT, right? So DIDT is getting is going down very fast. So VL will be very high initially, right? So that will get added. So EB plus VL, this is all momentarily, right? And now here it is already V, right? Say this is say at 200 volts, right? And EB as is at say, just a second, say, let me draw it again. Say V in is at 200 volts. Earlier it was driving the motor, but now the motor is supplying power to it. So it is off. Now this is happening. So VL and E back. Now E back, say it was a bit low, 190 volt. But if under this condition, can the power flow from the load to the source if E back is 190 and VL and V in is 200? Can the power flow? No, right?
No, no, sir. No.
Because the diode will be reverse biased. Now this is plus and this is minus. Now VL will be in the range of, say, it will just fall like this. It will fall like this, say. But here the voltage will be around 500 volts. Here it might be around 250 like this. It will fall down, right? So instantly when it is 500 volt, just see this voltage. It will be EB plus V in might be around, say, 700 volts, right? But here it will be only 200 volts. So the diode will get forward biased or not?
Yes.
Now, as the energy drains out, the value of E back will be almost decreasing, but VL, that VL voltage will now decrease, keep on decreasing, right? And before the whole voltage goes lesser than 200 volt, I'll switch this on again. I'll switch the switch on again, recharge, remagnetize the inductor, and I will again leave it back. Then this cycle will be continuing, right?
Oh, yeah.
So sometime will come when all the energy of this rotating DC motor will go down to the capacitor, and the capacitor voltage will increase. If you just go to the YouTube video that I had created on 4-quadrant chopper, you'll find that if the voltage is, say, 90 volts V input, the capacitor voltage rose up to 170 or 190 volts. If you have just some time, you can just check up after the class. You can just check out the voltage of the capacitor was very high then. So in this voltage, say it is going up to, in this case, say it is going up to 300 volts. So this kinetic energy of the motor will be stored as potential energy, electrical potential energy in the capacitor. Is it not so? I need a feedback. Hello. Abhijit, can you hear me?
Yes, sir.
Okay. So you people agree to this?
Yes. Yes, sir.
Okay. Just a second. Okay. So that was the regenerative action. So in regenerative action, what happens? The energy flows from the load to the source. So this is the graph with the regenerative action and motoring action for the chopper drives. So as the delta increases, so as the duty cycle increases, the motoring, the speed also increases, right? And if the regenerative braking is there, it will obviously decrease. This is the expression for it. We'll be doing some numericals for this. Now, welcome back to class C chopper again. I hope everyone remembers some amount of it, right? So the psychology of class C chopper, how did it come out? So this is class C chopper only.
Commission of buck and push.
No, not buck and push. This is a combination of both type A and type B.
Yeah.
Type A was what? It was only able to flow the power from source
Source to load.
to load. Type B was only able to do it from load to source. So
Yeah.
we need a bidirectional converter. So why bidirectional? Because we need to exchange energy in between the two things, right? Two sources. So what do? We make a type C chopper, which is the addition of a type A and a type B chopper, right? So what do we do now? make this arrangement. This is actually an IGBT which has an inbuilt body diode, and we attach the motor to this, right? So what is the best part of this? It is very simple in operation and very simple to make it also, right?
Yes.
Is it not very simple to do it?
Yes.
Right. So what will be the modes of operation of this thing? So let me discuss in a fresh one.
We have to give the name of the diode and resistor.
Yes. So first of all, we need to place a capacitor in parallel also, else regenerative braking will not happen. Right. So this is the complete IGBT, and now
The
for
capacitor is there for protection, right?
not for protection, to get the regenerative
For
energy,
storage charge. For
storing
storage.
the regenerative energy that will flow back to it, right?
Loading and transferring it to the battery, I mean, slowly or in a controlled way.
It will depend upon the battery how fast it will charge using. It might or might not get charged. It may be used in the next process of of motoring also, right? It may remain stored there. It will all
But
depend upon
sir,
the battery.
capacitor cannot store the power for longer time, na? So
Who
it
told?
should be done.
Who told it? If you charge a capacitor and if you leave it, the charge will be there. But that is
Yes.
not the
The
case
battery
for
cannot.
inductor.
Battery cannot
Sir, but it
last for
should
long
be
time.
as soon as you switch off the circuit or you cut off the power supply, it will discharge itself.
Where will it discharge? We, where will it discharge? That is the major difference between a capacitor and an inductor. Inductor cannot store that current. It will immediate. That's why it is called the kinetic energy, and this is called the potential energy. So if you are charging a capacitor and keeping it somewhere, if you just come after one day also, that full voltage will be there, almost the full voltage. That full voltage will be there. So if you are say charging a capacitor to around 200 volts and you're keeping it, you come after 5 days, it will be somewhat 200 volts only. Might be 2-3 volts down, but it will be same. But if you are charging an inductor, you are magnetizing an inductor say with 5 ampere, and the moment you leave it without a power source, immediately that it will get demagnetized, right? So that's why it is called the kinetic energy storage, and this is called the potential energy storage. If you don't believe me, just take a capacitor, charge it, see the voltage, come after 5 days, see the voltage again, right? Do the experiment for yourself, right?
Yes, sir.
So this would be the circuit for class C chopper. So tell me the operation. Tell me the operation of it.
So D1, S2, S2, D1, and
For,
S1, D2.
for motoring mode, what to do? For the motoring
S1,
mode,
S1, D2, sir.
S1, D2.
S1, D2.
yeah, if you turn on S1, what will happen? It will start flowing in this direction, right?
Yes,
It
sir.
will go to the motor and again it will go back to the source, right? Now, if you actually switch off S1, so S1 says switch off, then what will happen? The current needs a path, na?
Yes,
Actually,
sir.
it is an inductor also in the core of the motor, so it needs a path to complete itself. So where
Yes.
will it go? It will
So D2.
pass
So
through
D2.
D2. It will
Yes.
pass through D2, right? So D2 will act as a
Reading diode.
FWD, freewheeling diode, right?
Yeah.
So
Yes.
S1 and D2 are actually used for having this run
Motoring mode.
in motoring mode, right? Now coming back to regenerative braking mode. where you will actually use, just let me erase some things. So whenever you are trying to operate on some electrical system, just be aware of the capacitors. The capacitors are the most dangerous parts of an electric circuit. It may contain some charge without any visible signs of it, and then you may get a shock, right? Unexpected shock. So please be aware while working with capacitors. The most dangerous elements are them. Okay, so during the regenerative braking action, what will happen? Say S2 is switched on. What will happen? If S2 is switched on, the inductor will become magnetized,
Yeah.
right? And when S2 is switched off,
It will become
E
demagnetized.
back is actually adding up to the
Wind.
E back gets added on to the inductor voltage, and this is greater than the V in, right? If it is greater than V in, which dad will be forward biased? D1.
D1.
D1 is forward biased, right? So this operation will keep on happening until your wish, or till the entire entire kinetic energy of the motor is squeezed back and pumped into the capacitor. Now coming to the capacitor, what will happen to this stored charge, right? So this is at 200 volts DC, and the capacitor may have charged to 350 volts DC, right? So this point will remain constant at 350 volts, right? So, and in the next moment, if you want to go to the motoring mode, then tell me which one will first discharge, the capacitor or the battery?
Battery.
Why? The capacitor is a higher voltage, na? So till the capacitor voltage falls onto 200 volts, it will.
सर तो बैटरी तो सर लोड हो जाएगा और कैपेसिटर सोर्स हो जाएगा.
See, first of all, so what will happen? The capacitor will discharge first, right? So it will keep on discharging till the both the voltages are the same. So this will be 200 volts also, and this will be 200 volts also. So first, the energy that was stored in the capacitor is now reused for motoring now. So do you get it? See, which one will flow actually? The 200 volt DC will start flowing, or that the capacitor?
So the capacitor.
Why? Because it is a higher voltage.
Yes sir, is potential difference is higher than the battery.
Yes, so it will discharge fast. So
Yes sir.
see, these lines are having some amount of resistance, right? It is not lossless. It has some resistance. Now tell me which one will work. So if it is a like this type of thing, so this is say 100 volts, and this is say 200 volts. Now tell me which one should first discharge.
200.
First of all, this capacitor will try to charge up this, but this battery. But the charging of the battery will take a huge time, right? With huge time means what? Huge time with respect to the charging time of capacitor. The capacitor may get charged within seconds, say 1 or 2, 3 seconds, but the battery might take 1 or 2.5 hours to get recharged, right? So if it is at higher voltage, and if you are keeping the vehicle at rest, it will slowly keep on charging the battery, right? But if in the next moment you want to, say after 2, 3 seconds only, you want to go to motoring mode, what will happen? The voltage of the capacitor will get discharged till it is equal to the voltage of the battery. Is it not so?
Yes.
Sir, but 350 is battery.
350 is
Okay, okay.
350 is the capacitor. Right? The
Okay,
capacitor
okay, sir.
voltage will get higher charged up than the battery because the capacitor can accept the charges very fast, but it cannot. But the battery cannot accept the charges so fast.
Yes, sir.
Got it? So the the capacitor will get discharged like this, and it will now be equal to the battery voltage, right? So this was the operation of class C chopper. Now all
Can
these
you show me
things
the direction of current flow?
during which mode?
Regenerative braking.
Regenerative braking, it will start here, it will move through D1, then it will charge the capacitor and it will move back, right? And some amount of current, very small amount of current will go through this battery also. But the battery won't accept the charges so quickly. So forget this current. Only the capacitor will get charged up very fast and the voltage will be higher than the battery, right? It seems on
Sir,
this.
sir, simultaneously charging and discharging, does it affects the battery life? Sir,
Yes, up to some extent, but it is not so much. The energy required to recharge the battery cannot be fully obtained by regenerative braking, right?
sir, but the battery is having limited number of charging discharging cycles. Suppose
don't
3000.
think don't think it will be charging for 2.5 hours, right? The capacitor is of a very small quantity of power can be held by the capacitor, and the energy density of a capacitor is very high, but it cannot charge the battery like that. Only some it, if you just keep it like that without going to motoring mode, hardly it will be able to charge it to 1% also, right? So don't think that all the regenerative braking energy will take and recharge the battery. Forget that.
Sir, that capacitor is having 350 volts or 200 volts. How do you know that like it is always going to be having a higher volt than the battery?
Just a second. So first tell me, out of the battery and the capacitor, who is going to accept the charges fast? First of all, if they
Capacitor,
are connected
capacitor.
in parallel, if they are connected in parallel, if this is a 200 volts, this will be a 200 volts first of all, right?
Yes, sir.
Normally, under normal
Yes,
conditions. But when
yes,
there
sir.
is a regenerative action, when there is a regenerative action and the current tries to enter these two things, who is going to accept the charge fast? The capacitor.
Capacitor.
Battery is very slow with respect to capacitor, so this voltage might go up to only 1 volt, right? And this voltage will just jump up to around 350 volts or 400 volts, right? So which
Yes,
one
sir.
will be greater?
Capacitor.
That's it. Now these lines are having some resistance. Huh? Now tell me, when you are trying to discharge, which will get discharged first? So you are trying to discharge it through a resistor only. Now tell me, which one will actually get discharged first?
Capacitor
The
till it comes to
capacitor,
the
till it comes to the battery voltage, it will just say this is 200 volt and this is 350 volt, right? Now it will discharge like this, right? Sorry for the diagram, it often goes haywire. Now, so this is 350 volt, this is 200 volt. So this is the battery voltage, and the capacitor will discharge like this, and then it will be flat. Is it not so? Why
yes, sir.
flat? Now the battery will recharge the capacitor every time it gets discharged. So its maximum is 200 only. So it will be 200 only, and they are in parallel. Now, do you get the thing?
Yes, sir, I got it.
Yeah, you'll be seeing the practical implementation of it soon when we will be doing the 4-quadrant chopper. Okay. Is it time? We have 5 minutes left, so I'm leaving it to you that tell me if you have any doubts or other terms.
Yes, sir, I've got doubt.
Yes. Yes, speak up.
Sir, yes, sir.
Yeah, any doubts? Abhijit, any doubts? Okay. So, so here you might be seeing in some books that they're using thyristors as the switches, or as the case may be here, it is shown as here it is shown as the BJT. But in the true case, I must tell you, thyristors are never used in DC circuits, most of all, and not never in DC-DC choppers. Because if you turn it on, it is extremely hard to switch it off. You have to use uh, specially designed commutation circuits that will actually add on to the weight of the weight of the whole thing, right? So thyristors are never used nowadays. Earlier it was used when IGBTs were not so much popular. BJTs are also not used, right? PGTs are not used at all, right? So what is used?
IGBTs.
IGBTs, most important is IGBTs are severely used. 99% of the cases IGBTs are used. Where the frequency range is in within 100 kilohertz, there IGBT is used because the power rating of IGBT is very high, right? And not higher than BGT or thyristor, but the IGBTs are a good amount of power handling capacities there. MOSFETs are used where the power rating is low and the frequency is very high, right? So MOSFETs will be used when the frequency of operation might be going up to greater than 100 kilohertz, say 1 megahertz also. MOSFETs can operate at such a high frequency also. Here, IGBTs won't be able to work at such a high frequency. But the problem is that the power rating will be lower, right? So only IGBTs and MOSFETs will be used in DC-DC choppers. In say EVs, severely IGBTs will be used. MOSFETs won't be there. Yeah, some companies may opt to have the MOSFETs also, but 99% of the cases IGBTs will be there. And forget about thyristors and BJTs; they are outdated. Earlier thyristors used to be there, but nowadays not at all. Right. So just remember these points. Okay. So now we obtained all that thing in one quadrant only, right? Now what about the dual converter? We have already done actually, so I just skipped it up. Now what about both side operation? So I'll be finishing off with this. So does the black screen look nice to the eyes?
Yes, sir.
It is much more smoothing actually than the whiter one. So this is class C chopper, right? It has to have a capacitor. Without a capacitor, things will fail. The, the voltage of these lines will increase beyond limits and it may puncture the insulations also. And so never try regenerative braking without capacitors. You will end up with having the circuit failure. Now this motor was connected this side. Now I want to have it connected. I want to rotate it in both the sides. What will happen? How do I do it? First of all, it was only on one side. So what I do, I just flip over. So this was terminal A, this was terminal B, right? So I make another chopper like this. The same switches obviously. Can it not happen now in the reverse direction. See, if I turn on and off, if I operate S1 and S2, I am having the operation of the motor controlled in the clockwise direction, right? Now I want to go counterclockwise direction, CCW, right? So what do? I just flip over the chopper onto the next side. See, if I just short circuit it out here, can it happen now in the reverse direction? Is it possible?
Yes, sir.
So how do I short it using the switch? How do I short it using the switch? I have to use the switch and short circuit this A to this ground part. How do I do it? Tell me an option to do it.
Sir, S1, S3. Sir, S3 and S2 will be on.
Okay, I think we have already crossed our time. So we will continue this 4-quadrant chopper in the next class. And thereafter, this DC drive section will be complete. So unit 2 will be complete in the next class. Then we will start unit 3. Unit 3 is completely with AC drives, right? So let's meet in the next class and do the things. Okay, see you in the next class. If you have any doubt, you can ask right now. Okay, so meet you in the next class.
Okay, sir.